In this podcast, we're going to walk through how to add force vectors in 2 dimensions using right triangle trigonometry. The problem we're going to tackle is this one here. We have a stray dog and an alley cat fighting over an old rat. The dog pulls with a force of 57 newtons at 270 degrees. The cat pulls with a force of 45 newtons at 128 degrees. What is the net force acting on the rat? So we're viewing things from above, and we're describing directions in terms of the Cartesian method. So what I want to do for starters, just to help keep my direction straight, is draw a direction indicator on my page. Because I'm going to be drawing a free body diagram for my first step. That will show me all of the relevant forces that are acting on the object that I'm interested in, the rat. So somewhere on my page I'm going to draw a location where the rat might be. And from there, there's one force, the dog, pulling at a direction of 270 degrees with a force, the magnitude being 57 newtons. So that's my first force acting on the rat. The second force acting on the rat is the cat, pulling with a force of 45 newtons at 128 degrees. Now 128 degrees is somewhere between 90 and 180 degrees, so somewhere off in that direction. The magnitude I said was 45 newtons. And I just want to get a direction here. If I went in that direction there, that would be 180 degrees. So 180 minus 128 would give me this angle in here, 52 degrees. So that's my free body diagram. And that's going to be key for me in figuring out what to do next. My next step will be to resolve all of my vectors into their x and y components. I notice my first vector is already just in the y direction, so I'm just going to label that Fy. I don't have to resolve that one. But my second vector goes off at an angle. So what I want to do is create a right triangle, and I want to figure out how much of that force vector is going in an x direction, how much of that force vector is going in a y direction. I'm resolving it into its 2 components. So to find the fx component of that second vector, I'm going to use cosine. Cosine 52 degrees is going to equal Fx over 45 newtons. And so Fx is going to equal, when I punch it out in my calculator, 27.7 newtons. And I'm just going to write that right on my diagram here, 27.7 newtons. To find the y component of that force vector, I'm going to use sine. It's one of the safest things to use. So Fy will equal 35.5 newtons. So I'm going to put that on my diagram here, 35.5 newtons. So now I've resolved all of my vectors into their x and y components. My next step is I want to now add all of my x components together, all of the back and forth forces that are acting in this problem. So there is only one. It's Fx from my second vector, and the magnitude of that one is 27.7 newtons, and the diagram shows the arrow going off to the left. So because I'm adding vectors in 1 dimension here, I'm going to put a negative there to indicate the direction of that vector. So Fx negative 27.7. For the force vectors in the y directions, my first vector went off towards the bottom of my page. So I'm going to indicate that with a negative on the 57 newtons. My next vector, my other Fy, goes in a positive direction, so I'm going to leave that as a positive 35.5 newtons. So when I add those 2 together, my Fy comes out to negative 21.5 newtons. So now I've added all my x and y components together. I only have one x and one y component. My last step is to draw a final vector diagram. So in that final vector diagram, my Fx is off towards the left. That's what the negative indicates. So the magnitude of that component is 27.7 newtons. My y forces, the magnitude of that is equal to negative 21.5. So I drew an arrow going downwards to indicate the direction, so I don't have to put the negative in front of there anymore. So the magnitude 21.5. If I can now find the resultant of that vector diagram, that will give me my net force. The net force that's acting on this rat. So I'm going to use Pythagorean theorem to do that. If I go fx squared plus fy squared, add those together and take the square root of that, I'll get the net force. And so when I do that, 27.7 squared plus 21.5 squared, take the square root, I should come up with 35 newtons for the magnitude of my force. Now I also need to find the direction because we're dealing with vector quantities here. So I want to find this angle in here, theta. And to do that, the safest thing to do is use tangent. So I'll find a free space up close to the top here. I'll just box off an area. In that area, I'm going to find tangent of my angle. And so that will equal opposite, which is 21.5 newtons, over adjacent, which is 27.7 newtons. Cancel the newtons out, punch it into my calculator, and I should get the angle. The angle is 38 degrees. So because I'm talking about directions using the Cartesian method, I'm going to add 180 degrees to 38 to come up with my direction of my net force. So at 38 plus 180 gives me 218 degrees. So my final answer for this problem, the net force acting on the rat is 35 newtons at 218 degrees.